As to recall, this is not hard, but currently, early on, this is new to you, you're not used to it, where students often are going to make mistakes, and really it's the simplest thing. It's of all the things that we did, those little guidelines, the simplest one is one that students struggle the most with, and that's figuring out how many positions are available for the electrons. Remember, every element is 8, except for hydrogen, which is 2. So with that being said, ammonia, 8 for the nitrogen, 2 for each of the hydrogens, for a total of 14. Oh my gosh. Do you see where I'm going with this? It wasn't just you. Okay. How many valence electrons? Nitrogen has 5. Each hydrogen has 1 for a total of 8. Divide by 2, 3 bonds. Almost every molecule that I'm going to give you guys today will introduce a new thing, except for maybe the last one or two. So, once again, first element listed is typically going to be your central atom, unless otherwise noted. So we put nitrogen there in the middle. Doesn't matter where you put your hydrogens currently. And you make your 2 or your 3 bonds. Remember, each line represents what? But specifically, a pair of electrons, a pair of shared electrons. Now, we have 8 valence electrons available to us. We've used 6 for bonding purposes. We have 2 left over. What are we going to, we have to use them. They're in the system. Where are we going to put them? Well, your first place that you look is, do any of the peripheral atoms need to complete octets? The answer to that question is no, because hydrogen only needs to, it can only have 2 electrons. Each of those has theirs. The next thing you do is you look to see if the central atom needs to complete any octets. Actually, that's where they're going to go, regardless of whether they need them or not. You'll find that out later. The answer here is boom. Then you just check to make sure all your octets are completed and so on and so forth. With ammonia, it's pretty darn easy. Yes, Danny, what possible question could you have now?
So you have like NH3, but what if there's like more than 2?
Okay, next example. Oh, here's a pretty complicated molecule for you. Okay, let's have you guys try this one on your own. Okay, Bobby? Try this one on your own. I'll make this deal with you, Bobby. You get an A on the next test, I will not tell you to take notes anymore.
Oh, I need to take notes.
Oh, I know you do.
That seems just like a lose-lose for everybody. What, you getting an A? I think the A is a good part, but you're not taking notes.
Well, then why are you not taking notes right now? Well, I just graduated from college about 4 years ago, so... All right, so how many positions are available?
12.
That would be correct. How many valence electrons in the system?
4. I thought you wrote -8 for
Okay, it's possible that some people are still not following. So, 8 positions, 2 positions each. 5 valence, 1 valence each. Over here, 8 positions available, 2 positions each, 6 valence, 1 valence each. Okay? So anyway, with that being said, what's our central atom going to be? Hydrogen? I did not. But I'm going to let you use your brain. How many times can hydrogen bond? Once. That's it. So there's 2 things that common mistakes that some students will come upon as they're learning to do this is one of the more common mistakes is bonding hydrogen more than once. Hydrogen can never be a central atom. It's a one and done atom. Makes one bond, it is done. The other common mistake that will occasionally show up are Texas carbons.
Oh, 5.
Or more. What's the most number of times that carbon can bond? Because it has 4 valence electrons. Yet, I see people trying to bond 5 and 6 times with carbon, hence the Texas carbon. Because everything's bigger in Texas. Very good. That's good. All right, moving on. So anyway, what's our central atom? Right. Doesn't matter where you put your hydrogens or your bonds, but I'm just going to put them there for now. So we made our 2 bonds. We have 8 valence electrons in the system. We have currently used up 4 for bonding purposes. We have 4 left. Do our peripheral atoms need any more? They do not. So we put our remaining electron pairs around the oxygen. Are you noticing that I'm pairing the electrons up?
Yeah.
Did I introduce lone pair and bond pair yesterday? Okay. So here we go. This, in general, is called a bond pair of electrons because those 2 electrons are involved in a bond. These electrons are called a lone pair because they're not involved in bonding. A little bit later, maybe tomorrow, maybe not, we have to make some distinctions between bond pairs and lone pairs to figure out what shape the molecule is going to take. Anyway, use up all the electrons, follows all the rules, we're good to go. Any questions before I move on? Because I'm just going to keep throwing more things. Okay, here we go. What? Oh. Next. Try these 2 on for size. Oh, I heard a 16, a 14, an 18. I heard 12. I heard a 12. Is is not Free Association Day, Danny.
Free association.
When you're writing lyrics to your next song, free associate as much as you'd like. I have not, Danny. I will not.
Double bonds introduced here.
I'm sorry, what? Ooh, we just came into the new thing, the next new thing. All right, so carbon dioxide. How many positions are available for the three elements? Yeah, because there's no hydrogen, so each of the atoms is 8, so 24 positions available. How many valence electrons in the system? Well, we know that carbon has 4. Each hydrogen or each oxygen has 6 for 12. 12 plus 4 is 16. Whoa. 4 bonds. What's the central atom? Carbon. So we know we have to make 2 connections.
Yeah, you double bond it. Biology.
Okay? So I've used up 2 of the 4 bonds, but I have 2 more bonds. Where am I going to put them? Just like that. Now, of the 16 valence electrons, we have currently used up 2, 4, 6, 8. We have 8 electrons remaining in the system. Do we need to complete any octets for the peripheral atoms? Oxygen has its full octet?
No, oxygen only has 6.
No, it only has 4. 2, 4. Boom, boom. And same thing with the other oxygen. Well, currently no, but remember I'm trying to keep my electron pairs away from each other as far as possible, 2-dimensionally. We'll do 3-dimensional later. Anyway, so I've used up my bonds. Does carbon have its octet satisfied? Does it have 8 electrons available to it? Yeah, there's 2 sets of double bonds, so clearly it has 8. Okay, so carbon dioxide, done. Okay, let's go on to the ammonium ion. You don't know that this is the ammonium ion yet, but you'll learn that soon enough. So now we have a species that has a charge. I don't know what you're going to do with that electron. Right. Right. Oh, I thought you said add an electron. Oh, did you say take away an electron? So, here we go. So we have a nitrogen that has 8 spaces available. Each hydrogen has 2 spaces available, so we have a total of how many spaces?
15.
Thank you for you calculus students that don't add. And how many valence electrons? Nitrogen has 5. Each hydrogen has 1 for a total of 9. But the system lost an electron, so we have 8 electrons.
Over 2 equals 4.
So we put our handy dandy nitrogen in the middle. I know, I was just kidding. And so now we have 8 valence electrons in the system. We have currently used 2, 4, 6, 8 electrons for bonding. I'm out. Currently, I don't need any more for the peripheral. I'm out of electrons. Now, where'd that electron get lost from? It's a rhetorical question. It's a rhetorical question. The system lost an electron, so to show that the system lost an electron, we put the whole thing in brackets and put the charge on the outside. So that unit acts as a positively charged ion, just like the sodium ion atom acts as a positively charged ion. Anyone want to take a stab on now? So this one, I like this progression that I'm doing because we're just taking one thing and adding another thing. This one combines like 3 different things that we've learned already. Okay. So I'll let you do that one. What's that? Yeah. Yep. Excellent. Nicely done. With those 4 bonds, we need to connect 3 oxygens. Well, that only uses up 3 bonds. So now what am I going to do? I've got an extra bond. Double bond. Now, which oxygen do you put the double bond on? And excellent. We'll do the bottom one, but we're going to find out it doesn't really matter because it's really not there anyway, but that's for tomorrow's discussion. Now, with that being said, of the 24 electrons that were available in the system, we have currently used up 8. We have 16 left with which to complete any octets for the peripheral atoms. We have a lot of completing, don't we, to do? So I've got, what did I say, 16 left? 2, 4, 6, 8, 10, 12, 14, 16. For those of you that are fans of Monty Python's Holy Grail, you'll love doing this. Okay, moving on. Oh, but are we done? And there we go. Yes. I'm sorry, I can't hear everything that you're saying.
On the last one, why don't the hydrogens get the remaining...
Okay, time out. 80 electrons available. We've used 2, 4, 6, 8 for bonding purposes.
Oh, so they're just not using that.
What if there were some available to put on hydrogen? Would you? What's the most number that hydrogen can have, Rena?
1, 2, wait, I don't know what was the question.
You're falling at the end.
Wait.
Not studying from.
Hydrogen can only have 2 because it's
Right.
S orbital.
Right. There you go. You got it? All right. Onward. We're doing well. We're learning. Usually a question gets asked really, if it hasn't already been asked, gets asked very, very soon. Clearly it's not going to be asked yet, so let's just keep on going.
All those questions worth 6 points.
Each of those is worth 0 points on a test because you use the Lewis structure to do all the other things that were worth the 6 points. Right, correct. Next. Yeah, so don't screw this up. Try these on for size. I think at this point in time, you guys have everything you need so far until we get till tomorrow.
Do we need practice for this?
Oh, yeah.
All right.
In fact, I'm probably going to start writing that up right now.
1, 2.
Oh, we got all kinds of time. Oh, I forgot. We're going to have to come up with a new joke. That can no longer be known.
Acorn flat.
What is this?
Oh, it's Urban Meyer class. Oh yeah. They probably already worked with point of view. What was I doing? 2, 4, 8.
I'm sorry, what? I don't see why not. And 3 of them are Danny. You forgot that part.
Whoa, okay.
Can anyone tell me what's wrong with this picture?
He does that a lot, though.
Like 2 seconds ago. What, the fact that his son is up in school? I'm just trying to do my work.
Actually, it turns out, no, you weren't. Because I just took that picture a minute ago.
That should be your header on Twitter. Also, I don't know. He says he says I believe.
Hey.
Now the question is if I can open X.
How do you get positions? I'm sorry.
No, I know. I told you that this is the easiest piece, but it's the one that some people don't get.
Hi, I'm some people.
Yes, Bobby? I'm sorry, what? Here in a minute. You can check it.
Oh my, okay. Great.
So, this one has 4 bonds.
Thanks,
We
guys.
gave it a double bond here.
Got it.
Okay.
This one has 4 bonds.
I'm so slow. I'm not even
Okay.
Bond.
Single bond. Right? Okay. Well,
This one, we did double bond, so it's just single bond.
well, because this one we determined that there needed to be a double bond by doing that little calculation.
402.
All right, the SO3. I'm going to hope that you guys calculated 4 bonds. Excellent. Sulfur is the central atom.
Yes, I got the number of bonds right.
We make our 3 connections. That only took 3 bonds to do that, so we're going to put the extra bonds somewhere else. Currently, it doesn't matter because, like I said earlier, it's not even there. Let me see. There were 24 electrons in the system, correct? I've used up 8. There are 16 left. 2, 4, 6, 8, 10, 12, 14, 16. There is a valid Lewis structure for sulfur trioxide.
Okay.
So it doesn't matter whether it's the double bond first or the other, like the outer electrons. It doesn't matter. Like
You do the bonds first, then the electrons. Is that what you were asking?
yeah.
Okay.
But like, well, like when you add double bonds to get rid of
I didn't add double bonds to get rid of electrons. That's what you guys did in physical science. Okay. Over here we have well, it turns out you guys calculated once again 4 bonds. Okay, I'm going to go through it because I saw a lot of people. Okay, so we have 3 atoms that have 8 positions available. That's 24 plus 4 more. That's 28 positions available. We have 14 valence plus 2 more, which is 16, plus 4 more, which is 20. Carbon in the middle. Doesn't matter where you put the atoms, which atoms, put it that way. Doesn't matter which ones where. I've currently used up 8 of the 20 valence electrons that are available for bonding purposes. I have 12 remaining to complete any octets. 2, 4, 6, 8, 10, 12. Out of electrons. Anyone 2 for 2? Okay, good. Danny, go ahead.
Hey, you forgot to minus on the E.
Okay.
That's just like the...
Okay, over to HCN. I'm guessing you guys calculated 4 bonds.
Yes.
Excellent. So you put hydrogen as your central atom. No, we don't. So now we go to carbon. We know we have to make 2 connections. But there were 3 bonds that were calculated. So, double bond here, double bond there.
Well, you can't double bond on hydrogen.
Excellent point. Triple bond.
Triangle.
Okay, stop. Stop. You're fired. Why can't there be a triangle? Well, it's this 3-sided shape.
Hydrogen can only bond one time.
She's yours next year.
Listen, I just was thinking of symbols you drew.
I understand it, but listen, why can't that happen?
Hydrogen can only bond one time.
There you go.
Oh, yeah, so it could be.
I walked by and I saw Ichabod Crane and I was
I was talking about the triangle shape between...
Hold on, Mr. Borzak. Hold on, Mr. Borzak.
I know. No, I want to see crazier shapes.
Come on.
Are we talking about
This is what was currently up on the screen until my phone shut off.
It looks like, I say it because I don't really know what that is. It looks like something. I know it is there, but...
This is a triangle.
What is that?
I don't even know what that means.
You drew on your board before.
All right, anyway, moving on. There's 5 plus 4 is 9. There are 10 electrons available in the system. I have currently used up 8 for bonding purposes. I have 2 remaining electrons to complete any octets for peripheral atoms. Does the hydrogen need any more electrons? Does the nitrogen? Does the carbon? No, it does not. By now, there's been at least 2 questions that are typically asked. 0 have currently been asked.
I guess all my questions. How many bonds can you go up?
4.
Oh wait, the questions that you wanted to ask?
What are the questions that are typically asked by now?
What if you propose us the question and we say...
This is me.
Yeah, I'll try.
Because they look like numbers and tiny.
I would be bad. I'd be a bad chemist.
Well, we've seen 4 examples of what usually leads people to ask a question.
1, 2.
I just keep thinking of like tiny.
The double bonds.
That's sad.
Ah, good.
Wait, what did you say, dude?
Wait, you pointed at me?
What about them?
I don't know, there's 4 of them.
That's what I said.
Wait, can there
Yes?
be more than...
No, I didn't. Well, but we'll get into that later.
Wait, can there be more than 4 or no? Because like 2, 4, 6...
I'm sorry, what?
Like, why don't we ever put dots around like the center?
We will. Well, we did.
I was gonna say we did.
Oh yeah, you're right. Why is the one seven?
Okay.
Typically, by now, people ask, which elements can form a double bond?
No.
I have currently given you 4 of the 5 possible examples.
Wait, that's one thing carbon's notorious for, being able to...
Well, there's currently, look at the examples we have. Nitrogen, oxygen, sulfur, and carbon. We're missing one. No.
What, am I-
Ah, excellent. Phosphorus. Was that just a flat-out guess?
Oh, that's enough.
Oh, okay. You're onto something. So anyway, no, it's not that. It's not that.
Hydrogen can't double bond.
Thank you.
Oh, you're right. Then it's
So,
oh, yeah.
what elements are they again? You guys have to know those.
Shanoff without H. Better than what we were trying to do.
Oh my god!
Prison con.
Usually, another question is typically asked by now. But apparently, nobody wants to know.
Mr. Wayman Hollister said.
Well, we have another concept that was recently presented. Yeah. Another concept was recently presented.
Triple bond.
Yeah, what about them?
Which one?
Oh, that's a good question.
Yeah, I was gonna say.
Yeah, we knew that.
You did?
No.
Yeah. Because so it's the ones that only go to the 2 extra.
I don't know.
You're with me on that? Okay.
Aren't in the 3rd.
You just said it's just the ones that are left. Yeah.
I was talking to myself, you know.
All right. So anyway, those are the elements. Pecons are the ones that can form double bonds. Con is the ones that can form triple bonds. Well, I might as well do it. Just throw a little wrench into the plan here. Just for fun.
So really, carbon and I did ask for like triple bond. Yeah. In a roundabout way. The carbon.
Which one can quadruple bond?
Oh, close. I thought it was, wait, oh.
Ready, set, go. And while you're working on that one, I am going to write the assignment up on the board.
What elements can quadruple bond?
Oh, what the heck? No, right. Usually get the box by all of the curves when no one does that.
No, I think
Wow. All right. Mr. Lyman, seems we have run through an issue.
the next level.
There's an awful lot of bonds.
Mine is 40 times. I think I didn't miss it. And then F. 40 minus 30.
Oh my god, I keep forgetting they're all eight.
Yeah. 5 plus.
This exists.
6 plus 7 times.
Good try. Nope.
Did you guys get 40 minus 33? Yes, that's what it's like.
But then you get like 3 and a half.
Oh, was it? Did it turn out to be an odd number?
Yeah, that's what, I got 7.
Wait, we had to take away 1.
Okay. It still doesn't make any sense.
That does.
What is it? Which is 30. I remember when I did the math for that.
And there's 4
How do you do this?
Thank you.
Thank you, Brendan, for that first initial observation. Not that other people haven't made that observation, but you found out that something didn't match up. Brendan, could you please make that statement again?
You would have 3 bonds with 4.
Right. Can't happen, can it? Okay, this is your first clue. If your number of bonds that you calculated doesn't match up with what has to be done, that this is an exception. So, you calculated 4 or 3 bonds, but you know we have to make a minimum of 4 connections. Would you agree? I didn't say that.
He said it does exist.
So, you make your 4 connections that have to be made. No double bonds?
No.
Why not?
We already have more than 4.
There's they're not both pecons. So anyway, how many valence electrons are in the system? I already heard a bunch of people talking about it. 34. We've currently used up 8 of those. We have 26 left for completing octets. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 20, 22, 24. Well, wait a minute. Now what? Any remaining electron pairs you put around the central atom. Brendan, go ahead. Yep.
So does it cancel out?
Okay, we'll let you reconsider this tomorrow. No? Yeah, it's right there. You can take a picture. That'd be the fastest way.